Hello, and welcome to the tutorial video for Focus Quiz 5, Probability of Equally Likely Events / Binomial Theorem. It says theorem because your quiz says theorem. Technically this is binomial distribution. We will go over theorem, but not right now. I also want you to know that I recorded this whole thing already and had the wrong aspect ratio setting, so I have to do it again. If I sound exasperated, don't even worry about it. Okay. Probability of equally likely events is related to binomial distribution, but they're dissimilar enough that we'll be doing them completely separately in this video. A set of outcomes is equally likely when each outcome has the same chance of occurring as any other ones available. So you can think of flipping a coin, because 50% chance of each, rolling a die, 1/6 chance of each side on a normal die, things of that nature. And these do not always, but they often involve combinations. And you'll see that. This you'll want to keep in mind. The big P of something, doesn't matter, that is notation for probability of whatever. You might see that later in your high school, college career. And how we set up all these problems is the number of ways E can occur, and E can be very specific or very broad, over the total number of possible outcomes. All right? What is the chance of flipping a coin 7 times and only getting heads? The number of ways you can only get heads. So again, probability of E equals number of ways E can happen, number of E's, over all of the outcomes. The number of ways we can get only heads is 1. It doesn't matter what order you get them in, it's always going to be 1. And the total number of possible outcomes is 2 times 2 times 2 times 2, because you have 2 options for each one. So this will be 2 to the 7th. This will be something very small, obviously. So there's a very low chance you're only going to get heads. You will get problems like this. These are gimme problems. Don't miss them. This is more what you're going to have to deal with that involves combinations. And let's get into that. What is the chance of flipping a coin 7 times and getting 5 heads and 2 tails? Now, you only actually have to deal with one or the other of these because there's only 2 options. So when you do the combination of one, the other one is implied. And you'll see that. So how many different ways can E happen? You can get 5 heads in a number of ways. So you could get tails, heads, 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 tails. You could get heads, tails, heads, 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 tails, heads. You get the idea. The number of ways you can get 5 heads is 7, choose 5. You're choosing 5 of your 7 to be heads. And you don't have to do the 7, choose 2 on the other side, because the tails are, there's only one other option, so you don't have to mess with it. And the number of possible outcomes is the same, 2 to the 7th. And this looks like NCR 7, choose 5 over 2 to the 7th. 21 over 128. Another quick thing I wanted to show you is you could have also used tails here. For the same reason, if you choose your 2 tails, all the other ones have to be heads. And it would be the same. 7, choose 5 equals 7, choose 2. There is a thing that kind of shows this called Pascal's triangle that maybe you'll see later, maybe I'll show you later, I don't know. It never helped me very much. But this concept may or may not help you at some point. So I just do 2 random numbers that add up to the group you are choosing from. So 7, choose 3, and 7, choose 4. 4 and 3 go to 7. They're both 35. NCR 10, 2 and NCR 10, 8, both 45. That holds true for any number. Two numbers that add up to it are going to have the same outcome when put into the combination formula. Just a useful thing. What is the probability of drawing a 1, 2, or 3 when one card is chosen from a deck of 52 cards? So this is very different than this. This involves addition. We are only choosing one time. And we want to know what the probability of it being a 1, 2, or 3 is. So we have to figure out how many cards in a deck of cards fulfill that criteria. There are 52 cards in a deck of cards. Standard deck of cards. So whenever you get questions to do with them, 52 if they don't say it. There are 4 out of 52 ones, and there are 4 out of 52 twos and threes. One for each suit. Anyways. So our total is 12 over 52, or 3 over 13. I believe. Divided by 4. Yeah. So that one's pretty easy. And this is addition, again, because we are finding out what the probability of one event is. This is similar to counting problems, but instead of multiplying together different numbers of options, we're multiplying together probabilities. And this does not say with replacement, so that changes it. I'll show you why. We're filling in 3 slots. But these are probabilities instead of just integers, right? So what's the probability of drawing a 1 for our first one? Well, it's 4 out of 52. And then we look, what's the probability of drawing a 2 after that 1? There are still 4 2s in the deck, but there are only 51 cards left. And then for the 3, there are 4 3s in there, but only 50 cards. And that's going to equal 4 to the third over 52 times 51 times 50. I don't need to simplify that out. You get it. Equals answer. It's important to be able to tell which of these to do, because that's a somewhat easy mistake to make. You can also have these in combination. So if it said, what's the probability of drawing a 1, 2, or 3, and then a king, you would have to do this for the first slot, and then the second one would be different. There are 10 students in a class. 3 are girls, 7 are boys. If the teacher randomly selects 5 students with replacement, and that's what makes this problem easy, instead of a whole mess, what is the probability all are boys? So she's selecting 5, we're filling in 5 slots, and there's a 0.7 chance. You can do probabilities in decimal or fraction form or percentage form. Decimal is the most versatile, in my opinion, especially for these types of problems. So generally I'll stick with that unless it's much easier to write as a fraction, or you would get round off error like if it was repeating. Anyways, we're just going to fill each of these in. Because she's replacing, it's just 0.7 over and over. If it said something like an exact amount were 1, then we would have to use combinations and stuff. But you will get these types of problems, and it's as simple as that. Again, you will have problems with combinations, and you have to look out for it. It'll be pretty obvious. Binomial distribution. This equation is really ugly. I'm going to show you that it works. I'm going to explain it, and then I'm going to show you the easy way to do it in the calculator that is so much quicker that you should probably always use it. The only time you would have to use this is either they say, hey, which of these is the binomial distribution formula, and you have to know or be able to guess. Or if you take a class and you can't use a calculator and you have to know it for some reason, which can happen. Good luck if that happens. So let's explain it. An event with n outcomes has p that are considered as... This is not true. I forget. Ignore this. I don't know why they wrote that. I will simply tell you what all the things in here are. R is our number of trials. Okay? So think of something. The reason this is binomial is because everything can only be a success or a failure. So a very common one would be like free throws in basketball. You can either make it or miss. A coin flip. You could either get the side you want, say heads, or tails. So it only has two options. There can be any number of them. It just means pass or fail. R is your number of trials. So if you're shooting 7 free throws, R would be 7. S is the number of successes you want. So, I think this is how you spell successes. Don't check. S is the number of successes that you want. F is the number of failures that you want, which is equal to R minus S. It's the remaining trials. P is the probability of success. Remember, that's the how we denote probability of something happening. And Q is the probability of a failure. N, I don't really know why they include it. I imagine it does have an application, but because P plus Q equals N and P plus Q are always going to equal 1 because you can only either fail or succeed. Think of a coin flip. 0.5 plus 0.5 is 1. N here, it says, is equal to P plus Q. It's pretty much always going to equal 1. And when it equals 1, the R to whatever just makes it 1, so you kind of ignore it. You're just looking at the top part. So let's do some problems. If a coin is flipped 7 times, find the probability it will be tails exactly 3 times. So I'll do this with the equation, which again, we kind of ignore this. And then I will show you the easy way to do it, because things like this, probability it will be tails at least 3 times, take you literally 20 minutes to do with this. You can, but it's hard. So let's do it with the equation first. R, our total number of trials, is 7. We're flipping it 7 times. S, we want to get it exactly 3 times. That's our success. And then the probability of success is 0.5. It's a coin. To the third, because that's how many successes. And then the probability of failure is the same. And then we raise it to the fourth, the number of failures. That's the only place the F comes into play. And then we will go type this in. Remember when I recorded the whole video and then had to restart? That's what that is. It's the R 7, 3 times 0.5 to the third times 0.5 to the fourth. And that's our probability. Now, I'm going to show you how to do it the way that you probably always should. There is a function for it in the Inspire. You go to Menu, Probability, same thing as permutations and combinations, but we're going to go to Distributions. And the ones we want, these are for like statistic stuff, we want A and B. Binomial PDF is for one singular number of successes. CDF is what we'll go over in a sec, but we're going to do PDF right now. Our number of trials was 7. The probability of success, or in this case a tails, was 0.5. You can also do 1 over 2. You cannot use percentages here. And our number of successes that we want is the X value, 3. Exact same number. So as you can see, you're probably going to want to use this most of the time. Let's go back and we're going to look at the probability it will be tails at least 3 times. So normally, or not normally, but if you had to use the equation for this, you would have to find this, which is 3 times, and then you would also have to find, ignore that, 4 times and 5 times. You'd have to do all of them and add them up. You don't want to have to do that, especially on a timed Acadec test. There is a function for this. We're going to go to Menu, Probability, Distribution, same kind of place, and this is B. You can click B and it'll do it. I usually just scroll through the list. The number of trials is the same. Probability of success is the same. But now we have a lower bound, which is 3 successes, and an upper bound, which is 7. We can get between 3 and 7 successes and satisfy our criteria. And that is the probability of getting at least 3 tails, or heads, it works the same way, if you flip a coin 7 times. One more problem like this. A basketball player makes 65% of their free throws. If they shoot 7 shots, what is the probability they make 4 of them? So this is very similar, but it has a different probability. I'm not going to do it with this. You've seen how that works. We're going to immediately go to the other one. So we want to know the probability that he makes exactly 4 shots. He's shooting 7. There's a 0.65 chance that he makes it. And we're looking for exactly 4. And again, PDF is for just 1. And once you get in the menu, you'll know that. But anyhow, that's the chance that he makes exactly 4. Now we're going to see what's the probability he makes at least 4. So instead of PDF, we're going to use CDF. Our number of trials is still 7. Same probability. But our lower bound is 4, and our upper bound is 7, which is all of them. And that's the probability he makes at least 4. Pretty good. Actually, I don't know what good free throw percentages are. This one might be really bad. I just wrote the problem. And now we're going to do the flip side, which is very similar, looks a little different. What's the probability he makes at most 5? CDF. Number of trials, 7. Success, 0.65. Now our lower bound will stay 0 because he can make none of the shots. And our upper bound will be 5. And that's the chance he makes between 0 and 5 inclusive of his free throws. The one thing you have to watch out for with these kind of problems is they can write it instead of like at most 5, they could write more than or less than 5. And if they write less than 5, then you're actually looking for 0 to 4 inclusive. You just need to watch out for the wording. That's what can mess you up the most. But that's all I got for you for this. I do think at some point later to prepare you for like regional and state tests, there will need to be an advanced video on these 2 topics. I'll have to see what this year's math is like. This is as simple as they get. Can get a bit harder. Good luck.